All right, so this video will focus on 6.2, and the first thing you have to do is just go through and name the ordered pair. So pretty easy, 4, 1, and this one, of course, is 1, 3. We're going to try to represent a function in different ways today. So the first thing is we're looking at these shapes. We're going to put an input in and then get the output. Now you have to know the formula for these shapes, right? So I know that it would be 1/2 length times width. So in this case, if I plug in a 1 here, I have 1 times 4 divided by 2 is 2. If I have 2, 2 times 4 is 8, divided by 2 is 4. And it just keeps on going up by 2 each time, essentially, right? And then this one here is 8. Let's just make sure of it. 4 times 4 is 16, divided by 2 is 8. This one here is base 1 plus base 2 divided by 2 times height. So if I look here, if I have my 1 times 2 is 2, plus 1 is 3, divided by 2 is 1.5, times 2 is 3. If I plug a 2 in here, that's 4, plus 2 is 6, divided by 2 is 3, times 2 is 6, and so on. And my answers are going to be right here. So I'll have a equals 2x in this case, and a equals, it looks like it's going up by 3 every time, right? That's what's really happening. If I look at this, we want to try to figure out if this is, can you find the horsepower of a race car engine if you know its volume? Well, remember the whole thing that when you map these out, so if I have like 200, and then I have 375, that's my input and my output, and now I have 350, and that maps up to 650, and now I have 350 again, and that now matches up to 250. The point is I already had it once, right? So I can't have it twice, and this has 2 different outputs, so this is not a function. It doesn't work. So we go through here, and that's what it's showing, that it's a false statement. This one here, describe the graph using the graph to predict the cost of 8 tickets. So it seems like 1 ticket is $6, 2 is 12, 3 is 18. What do you think 8 would be? Well, hopefully you understand that as I go, it looks like the unit price for a ticket is $6. So if I know that it's $6 for 1 ticket, well, if I want to figure out 8 tickets, I could then multiply this times 8 and I get $48. Or I could just do cost equals 6 times the number of tickets, right? And that will give me the cost. So basically we have our function rules, which is what we were doing in the last lesson, where we go through and kind of describe what's happening. So in this case, if I put in a -2 for this 3x, right? So 3 times -2 is -6. My output will be a -6. And you probably saw a function machine like this back in like 5th grade. We're going to kind of go back through this again, make sure you really understand it. So write a function rule for the output is 5 less than the input. Well, if I have the output is 5 less than the input, then I have y, which is the output, is 5 less than the input, so x minus 5, and that will equal my y. So the output of the output is the square of the input. So I put the output, and then I put down the input squared. So in this case, it'd be y equals, and I have my x squared. So here's my function rule. When I plug this in, I'll receive this value. If I plug this number in, I'll receive a value. So what is the value of y equals 2x plus 5 when x equals 3? So if I take this thing and I plug it right into here, 2 times 3 is 6, plus 5 is 11, right? So then my ordered pair is 3 and 11. I can then map this out where I'll have my 3 and my 11, if you want to map it as well. So the output is 1/4 of the input. So again, it's my output, which is y, equals 1/4 x. And then these, which I'll get to in a second for the answer, but if I plug in a 5 into these, what is my value? So this is 20 minus 1 is 19. This is 50. This is going to be negative 15 plus 7, so that's negative 8. So here are all the various values. We could write these things as tables. So we have my input, my output, my ordered pair. We can graph them out. We could also map it, can't we? We're going to now plug these different points in. So if I plug in a negative 1, I'll have a 2 plus 1 is 3. A 0 is 1. A 1 is negative 1. And a 2 is negative 3. And here's the various table. And if I look here, it appears that this value is going down by 2 every time, right? And this is increasing by 1 every time. And if I plot the ordered pairs, if you look here, I'm going down by 2 over 1, down 2 over 1. So I'm actually graphing it now as well. So graph this function. So we've graphed things for a while. My starting point, of course, is 1. It goes up 1, over 1, up 1 to the right 1, up 1 to the right 1. This one goes down 1 to the left. Down 3 to the right 1, down 3 to the right 1. This one, of course, starts at 2. It goes up 3 to the right 3, or right 1, up 3 to the right 1. And here are the various graphs. And then if the last thing here is the number of pounds P of carbon dioxide produced by a car is 20 times the number of G gallons of gas used by the car. Write a graph and function that describes the relationship between G and P. Well, I know that I have my P equals 20 G is what it just said. And here's how you write it. Let me just move this out of the way so you can actually see it. Here's the ordered pairs. And then the graph, of course. So these are the various ways that you could actually represent functions. And that is